Welcome back, everyone. We now move on to our second session of the day. I invite Ms. IP Pavitra, Assistant Professor from EC Department, to give an introduction of our chief guest.
Good evening, everyone. It's my great pleasure to introduce today's esteemed resource person for our Atal FTP program. Dr. Ravi Samikannu graduated with his PhD in Electrical Engineering from Anna University, India in 2012. Currently, he is working as an Associate Professor of Electrical and Communication Engineering Department in Botswana International University of Science and Technology. Prior to joining BIUST, he had held variant research positions in different universities at India, Malaysia, Ethiopia, Algeria, and Tanzania. He received total grant of 3,58,187 US dollar from funding agencies. Under his supervision, 6 PhD scholars, 45 master students, and 65 undergraduate students completed their research. His main research focus is on power system, renewable energy, intelligent algorithm, biomedical image processing. Professor Ravi has published more than 100 peer-reviewed scientific journal paper, 60 conference paper, 4 books, 2 edited books, 2 book chapter. His work has been published in the leading international conference and journals. The research work published in different publishers such as Elsevier, Sage, Springer, Wiley, MDPF, Frontiers, etc. He has been very effectively involved in the service for the community in terms of acting on various positions for the international leading conference in the field of electrical electronic engineering. He also serves on the editorial board for more than different journals and edited different special issue journals. He is actively engaged in teaching, research, and academic administration. He has played a significant role in setting up the various laboratories for different electrical engineering courses and prepared for the department for accreditation from other quality agencies like ERB, BQA, NBA, AICTE, and UGC. He is an active member in IDDS and participated in different rural community development projects. Now, I hand over the session to the resource person. Sir, please.
Thank you, madam. Thank you for your introduction. Am I audible?
Yes, sir.
Okay. Thank you for giving me an opportunity. I want to say my sincere thanks to the management, Department of ECE, and Professor Pichinaya for giving me an opportunity to give a speech on smart grid communications. I just want to project my slides. I have projected my slides. Is it visible?
Yes, sir, it is visible.
Okay. Okay. Thank you. My today's topic it is smart grid communication, secure transmission through the optimized trusted code matching. So myself, I am Ravi Samikannu, working as an associate professor in the Department of Electrical and Communication System Engineering, Botswana International Institute of Science and Technology, Botswana. Okay, so everyone we know, generally, here we are going to talk about the smart grid. Before going into the smart grid, we need to know what is an electrical grid. So electrical grid, it is a very complicated system. Normally, electrical grid, we can say it is in other name as electrical power systems also. So if you look, the electrical power systems, it is going to have different units. Like we are going to have the generation of power, then the generated power, it is going to be transmitted and distributed to the different consumers. So consumer, we are at the last. So if you see, we are having different generating stations. These different generating stations, they are placed in the places where we have the resources. Example, in some places, we may have a coal resources. When we have a coal resources in a particular place, we are going to construct a coal-based power plant where we can able to get the coal. In some places, we are going to have the hydro energy. So when we are having the hydro water resources like a river, what we do normally, we are going to construct a hydro power plants in the places where we are having the hydro resources. Then, if you see, when we are having a wind resources, in the place we are going to construct the wind power plant. So solar power, all over the world, solar power we can be able to get in maximum places. So wherever we have more solar radiation in the places, we are going to construct a solar power plant. Other than this, we can use a tidal power plant. We can use oil, gas power plants. Then we can use nuclear power plants. So these all power plants, if you see, we are going to construct them where we are having the resources, right? So what is happening is we are going to have a power plant 1, power plant 2, power plant 3, power plant 4 in different locations. After generating the power from these different power plants, we are going to transmit the power. So the power it is transmitted, okay, in a high voltage. Then again, the power it need to be distributed to the consumers. So if you see the consumers, we are having a different varieties of consumers. Maybe we have a industrial consumers, we have a commercial consumers, we have a household consumers. So the power is distributed to these consumers based on their need, like based on the power supply, whether they need a single phase supply or a three-phase supply. That's what if you see in the first slide, resources, we are not having it available in all the places. Even if you see some countries, they are mainly depending on the coal power plant. Some countries, they are depending on the hydro power plant. Some countries, they are depending on the renewable energy. Some countries, they are mainly depending on the nuclear power plants. So the resources, it is not available in all the places. Power, it is generated at different generating stations based on the available resources. Then it is connected in the grid. So if you look, this is the structure of the power systems. So here you can see we have a power plant. This power plant, it is going to generate the power. The generated power, it may be in any ranges. It can be in the ranges of 11 kV or it can be in the ranges of 33 kV. So the generated power depend upon the capacity of the generator. So if we are going for more rating, then what is going to happen is we are going to spend a lot of investment in the power plant. And also we need to look about the insulations and other parameters. So we are having different ranges. Here an example, it is mentioned as 11 kV or 33 kV. We are going to generate from this power plant. Then next we are going to have a step-up transformers. So everyone we know why we are going to use a step-up transformer is because when we are transmitting the power in the ranges of 11 kV or 33 kV, it shows like the voltage value is less and the current value is high. So it may leads to a I squared R loss. So to eliminate that loss, what we are going to do, we are going to use the step-up transformer, step up the voltage, the step up the voltage through the different supporting structures because the supporting structure is a very one important component in transmitting the power. We have a conductors, we have a cross arms, we have a supporting tower. So we are having different types of supporting tower depend upon where it is going to be used, whether we are using a steel tower, wooden pole. So we use a pole when it is coming to inside the urban or inside the rural area. But outer areas, we normally use the steel towers. So here, if you see, we are stepping up the voltage to the range of 132 kV or 220 kV or 400 kV. The stepped up voltage transmitted. So everyone we know we are having different types of transmission systems. Primary
Ravi
transmission
sir,
and the yes,
your voice is
yes.
please little slow, sir.
What about now? Is it fine now?
Yes,
Is it
sir.
fine?
Yes,
Okay.
please. Yes, sir. Okay, sir.
Okay. Thank you. Thank you. Okay. So if you look, we are having a different types of transmission systems, primary transmission, secondary transmission. So in the primary transmission, the voltage it is stepped up to 132 or 220 or 400 kV. Then again it is transmitted in long distance. So we are transmitting in long distance with a high voltage to reduce the I squared R transmission losses. Then again, when we are entering into the secondary transmission, we are going to use the step down transformer. The step down transformer, it is going to step down the voltage from 400 or 220 or 132 to 66 kV. Then again, we are having a sub transmission system. We are transmitting the power. Then again, we are going to have a step down transformers. After this step down transformers, we are going to have a distribution systems. In the distribution systems, we are having a primary distribution and the secondary distribution. So again, the voltage is reduced to 11 kV or 33 kV. Again, if you see, it is again reduced to 230 or 440 voltage, 415 voltages. Then it is supplied to the industry. So if you look this 220 voltage or 230 voltage, it is depend upon the countries. Some countries they are using the voltages in the ranges of, if you look, they are starting with 100 to 120. Some countries they are using the voltage ranges from 220 to 240 voltages. Okay, so countries like Japan, countries like US, they are using the frequency of 60 hertz and they are supplying with 120 voltages. And then other countries they are using the frequency of 50 hertz and supplying with the 230. So we are having a different types of consumers. All these consumers they are getting the supply electricity from this power plant. So this is the lengthy process, and if you see, this is a very complicated system which is having so many components in it. Like we are having a generators, we are having a transformers, we are having transmission lines, we are having a conductors, we are using different protection devices, and then we are having different supporting systems like a cross arms supporting towers, poles. Like we are having so many components like power factor correction devices. So this structure of the power system is very complicated. When we look the world electricity generation by source, if you look maximum we are depending on the coal power plant, and then next to the coal power plant we are having the gas, and then we have the oil, and then we have the nuclear. If we look how much the renewable energy is contributing for the total electricity generation, it is very less, but there is an awareness now, and also all the countries they are agreed towards moving for the renewable energy resources. So now countries they are interested in investing in the renewable energy power plants by reducing the coal usage, gas usage, and the oil, because as these resources it may be depleted in upcoming years. So we need to look some alternatives. That is the reason we are going to use the more renewable energy sources which is available for free. So when we look Indian electricity generation by source, if you look at the Indian electricity generation by source, it is also same like the other countries. Mainly it is depend on the coal power plant, then it is depending on the hydro power plant, then it is depending little bit of nuclear power plant, then other renewable sources like solar and wind. So this is the generation by source for the Indian electricity. Okay, now when we look why we are going for a smart grid, when we are looking about the why we are moving to the smart grid, we are having so many problems with the existing conventional grid which we are using now at presently. Generally if you look, we are having majorly a problem inadequate last mile connectivity. So still some of the villages they are not connected with the electricity. If you look compared to the world, especially the continents like Europe, Asia, they are then no, then North American countries they are electrified a lot compared to the other continents like islands in South Pacific, then countries in Africa. They are not connected like 100 percentage. Some countries they are having a electrification rate of 20 percentage, 25 percentage. Even if you see if they have a 50 percentage of electrification rate, you can see the 40 percentage they are mainly concentrating to supply the power to the urban areas, but the rural areas they are with less electricity. So connecting everyone to the electrical grid it may be very difficult, because when we look, maybe we may have a village with a less number of populations, but they may be far away from the grid. So we need to extend the grid. It may make us to invest a huge amount, so that may be a problem. Then if we look unequal electricity distribution, you can see we have a different types of consumers. We have a consumers from the urban area, we have a consumers from the rural area, and we have a consumers like industries, we have a consumers like people in the village. So we have a priority, like we can say industries is need to be supplied all the time, because they need to produce a lot of items. So if you look, the electricity distribution is also not equal, and there is a changes in the power pricing always, and also we are having majorly the transmission losses, and also we have always the resistance to the power project when we want to acquire lands. Okay, we need to get approval from the different organizations. Okay, we need to get the environmental ministry approval. Like we always face different problems. And other one major issue is theft of power. It is a major issue in many countries. So these are the different problems we always face with the power systems when we are developing a new power plants. And also when we look new power plants development, it need a lot of land acquisition, and we need to have a availability of the land, and getting a clearance, it's difficult. Now, if we see in total the conventional grid, what we are having presently, it is having a lot of issues like grid operation. It is a complex one, and also expanding the network is difficult, and always we have a grid disturbances. So when we are having a heavy load is connected, or when there is a loss of a power plant, then automatically we get a grid disturbances. That is a major problem, leads to the challenges in the grid operations. So why we are moving to the smart grid from the conventional grid? The conventional grid, it is faced so many problems in this last 100 years. Okay, if we can see here, I just mentioned some of the blackouts which is happened. mm, that blackouts, it is affected so many people in different areas. Like if we can see a northeast blackout 1965, it is affected more than 20 million people. And then the energy crisis, it is happened because in Arab there is an prices for the oil, it is increased in 1973-74. In that time only, after that time only, India is concentrated towards investing for projects for other renewable energy generations. Then Western energy crisis that is happened in 2000 and 2001 affected around 1.5 million customers. So here I am showing a picture. That picture, if you see, it shows like what are the different blockouts it is happened after 2000. So you can see some of the blockouts it's happened at the United States and Canada. And in India also, we got an blockout between July 30 to 31, 2012. And then if you see other South American countries like Venezuela, Brazil, and Costa Rica, they are also affected by the blackouts. So if you see all the continents, they are affected by the blackout for some particular reasons. So challenges in grid distribution sector, if you see, as we know already, the losses is more, theft is there, and then we can see we are having a different transmission our distribution systems which we are using the old methodologies. There may be a possibility of commercial leakages. These are the major problems which makes us to change the conventional grid into a smarter grid. Okay, what is a smarter grid? Smarter grid, it is a way to upgrade the existing grid in smart way. So if you look a simple way, generally, if you look the existing grid, if you look the 20 years before, if you see a customer cannot interact with the utility grid. So utility grid is the electricity board. We can say utility is like electricity board, water board, everyone, they are coming under the utilities. So if you look the utility grid, we cannot able to access the utility grid, right? We cannot able to approach the electricity board very easily in earlier days, but now it is very easy for us because we have a different types of facilities, like we can able to call them through the customer care. Even you can message them to report the incident, what is happened at the house, or what is the incident happened at the area, so why there is no electricity. So many communications improved nowadays in the smart grid, but in the existing grid it is very difficult. If there is any problem in the house, you need to go to the utility grid and you need to report. So if you look a smart grid is an intelligent electricity network that integrates the action of all users connected to it and make use of advances information control and communication technologies to save energy, reduce the cost, and increase the reliability and the transparency. So the reliability, it is going to be increased, and also we have an opportunity to interact with the grid. So all the users, they can connect it to the grid, they can use ICT technologies. So we are having a conventional grid, then conventional grid, it is upgraded into a smart grid in a smarter way. So Okay, now I just want to give explanation about smart grid. In the smart grid, what we are going to do is we are going to use information and the communication technologies to improve how the electricity travels from the power plant to the consumers. Always the consumers have the opportunity to interact with the grid, and also we can able to integrate different new and improved technologies in the operation of the grid, as like you have seen in the previous presentation. You have seen the IoT can be implemented in the smart grid, and also we can use different sensors in the smart grid. So many operations we can able to do in the smart grid where by using the improved technologies. Okay, why energy or electricity is very very important? It is very very important because as like how we are giving importance to the per capita income, the same way per capita energy is also very very important. So if you see the countries where they have electricity, their growth is different. Some countries where there is no electricity, their growth is not that much up to the level. So supplying electricity or giving electricity to the consumers, it is also a very very important. Now every country's economic and social welfare, it is mostly rely on the electricity, right? Even if you are having a daily operations in industries or any other purposes, even if you want to run a shop, if you want to run a hospital, if you want to run a universities, if you want to run your house in a day, everywhere we need electricity. Okay, so when in smart grid, what we are going to do is we are going to include electronics and communication infrastructures, advanced process automation, like we can include SCADA, we can include DCS, like then we are going to use the information technologies. So smart grid, it is going to think about how it is going to deliver the electricity and its related services. So energy industry, we need to modernize the energy industry. Our existing electrical grid, it need to be modernized. That's why we are going for a smart grid. So here I am showing a picture. If you look this picture, you can see the overview of electric utility industry and the grid systems which we are going to have in future, and in some of the things it is already existing now with us also. So if you see the past systems, it is having a substations, it is having a system operators. If you see, we are having a transmission, and then you can see the system operator, he can able to interact only with the substations, and they can able to supply the power to the consumers like industrial consumer, commercial consumer, and residential consumer. This is the fast system we used to have. Then present grid systems, if you see in the present grid systems, what they did, like what we are having now, the consumers are same: industrial consumers, commercial consumers, and residential consumers. But we can see here we have some um, we are including some of the renewable energy resources generation like a wind power plant, solar power plant, it is included. And instead of a system operator, we are going to have a transmission control center and a distributor control center. So these control centers, they have the interaction with the transmission and the distribution systems, and also they are going to have a communication with the substations also. Okay, so is this is enough? No, this is not enough. So when we look how we can able to modernize the existing grid, we are modernizing the existing grid, that is a future grid or a smart grid systems. In the smart grid systems, we are going to have a transmission control center, distributor control center like the previous one. Additionally, we are going to have extra like other way of generating energy resources, and also we have the facility to use electric vehicles. And you can see here we are having a energy service provider. Now, if you look maximum all over the world, only the government, they are the one who run the energy industries. But now individual power producers, like anyone can start their own power plant and they can generate power, and they can use the utility grid, the transmission and distribution systems to supply the power to the industrial consumers, or even able to sell the generated power to the government also. So we are going to have IPPs, right? So these are the facilities which we are going to have in the smart grid systems. Okay. So here I show a difference between the conventional and the smart grid systems. So conventional grid systems, one-way communications. There is no two-way communications. Here now I can able to communicate with the utility grid. I can get the response from them. And centralized generation. So the major problem in the conventional grid is, as you know, the grid maintain controlling the grid, operating the grid. It is a very complex, as the system is a very bigger systems and it is a complex system. So normally what they are doing is we are using a centralized generation, but now we need to go for the distributed generation. So what is a distributed generation? Distributed generation, like example, you have a village. In that village, you have 100 houses. That 100 houses need to be supplied with electricity. Instead of connecting these all 100 houses to the grid, what we want to do, we want to generate our own electricity in that village itself by using a solar or by using a wind resources. That generated power, it should be supplied to the consumers in that village, so that we no need to extend the grid to the village. So when you are extending the grid network, it is going to make you to invest a lot of money to supply only 100 houses. And also, when you are having a distributed generation where you generate power and supply to the consumers in the place where they need, it is going to reduce the cost and the complexity. So we are having less sensors in the conventional grid, but in the smart grid, we are having more sensors. Manual monitoring, here we have a self-monitoring. Manual restorations in conventional grid, in the smart grid, we need to have a self-healing nature. And there is a lot of blackouts and failures in conventional grid. But in smart grid, it can able to adapt to the situation, and also if there is any fault happens, it can able to islanding the particular network. Then limited control. Here we have a pervasive control. Few customer choices, as I told you earlier. I know in conventional grid, I have only one opportunity, or I have only options to get electricity from only utility grid. But when it is comes to the smart grid, you have the opportunity. If you feel like, no, I want to get electricity supply from the supplier A, you can get the supply from the supplier A. If you feel no, supplier A is not okay, you can go to the supplier B. Like how you are using telecommunication networks. That way, even electricity you can get from different suppliers in future in modern or smart grids. So here we have a principal characteristics, and then I have a you can see the comparison between the today's grid and the modern grid. So if you see a lot of advantages we are having in the modern grid over the today's grid, like in self healing, the modern grid, it can able to detect automatically if there is any problem in the transmission and distribution systems, and it can able
Sir
to,
Ravi sir,
yes,
you can increase your volume of systems.
yeah,
It's
yeah.
little.
Is it fine now? Is it fine now?
Yes, sir. Participants are repeatedly posting the message in the chat box.
Okay, but okay. Is it fine now?
Oh, yes, sir. Yes, sir. Yes, sir.
Okay,
Okay, sir. Thanks.
okay. So if we look here, we are having a different differences between the today's grid and the modern grid. So the modern grid, it is having a lot of advantages, like it is having a self-healing nature, and it can able to include the customers, motivate the customers, so that it can able to resist attack, right? And also the improved power quality, it is possible in the modern grid systems. And also it can able to accommodate all generation and storage options, like we have the opportunity to add the electric vehicles, and also we can able to add all type of generation units into the grid systems, and we have the facility of adding storage units. Then we can able to enable the market also, like as I told you earlier, the individual power producers, they can able to sell the power to the customers when we are having a smart grid systems. So when we are looking the smart grid systems, five major groups we have in the smart grid systems. The first one is policy and legislative drivers. In that, we are going to talk about the electricity pricing and the options of smart grid. Economic competitiveness, it's deal with the green jobs and technology regionalization, then energy reliability and the security. So we can able to improve the reliability and we can reduce the theft and the loss and we can able to do the energy management. Additionally, we are having a customer empowerment like customers. We are going to interact with the customers so that we can able to get the satisfaction of the customers when we are supplying the electricity to them. Then environmental sustainability, as you know, we are going to add more renewable energy and a distributed generation integration, so that will help us to reduce the carbon emissions also. So the smart grid, it is going to help us in resiliency, availability is more, scalability, different areas, reliability, stability is more, security wise it is fine. So benefits of smart grid, the smart grid operational wise efficiency it is going to be improved because as we are going to include the distributed generations, as I told you earlier, when you are including the distributed generations in the grid, automatically it is going to supply less customers and it is very easy for us to manage the distributed generation plant, and it is easy for us to use the assets and the resources. And also when we are coming to the energy efficiency side, we are going to reduce the losses because you know the existing network it is using the old technologies in the transmission and distribution systems, which is going to results in the losses can be modified and the energy efficiency can be improved when we are going for the smart grid. And also we are going to add power quality components like reactive power compensation devices in the grid. Customer satisfaction, previously we know we are very, it is very difficult for us to approach the utility grid, but now it is very easy for us to reach the customers. Customers can reach the utility grid very easily, so there is a bi-directional communication between the customer and the utility grid. And the last one is about the green agenda. More renewable energy resources it need to be included, and by using more electric vehicles or by using more renewable energy power plants. So these are the different benefits of smart grid. So when we look the smart grid technology, it is included in all these places, like we are having a generation, then we are having a transmission, then we are having a distribution, the consumers we are having industrial consumers, commercial consumers and the residential consumers. So if you look the smart grid technology, we are having a different types of smart grid technology. Here in the smart grid technology only we are going to talk about the smart grid communication development. So the wide area monitoring, production and control, if we look, it covers the generation, transmission and distribution. When we are coming to the industrial, commercial, residential, we are having a automation. Earlier days, we don't have any automations in the buildings and the industries and in the houses, but now we are having a good automation systems. Then generation side and the transmission side, we are going to have a large scale renewable generation. So you can see nowadays they are constructing different types of renewable power plants with a huge huge value of watts, right? In megawatts, they are constructing the power plants. Then productions we are going to use automation, we are going to use voltage and reactive power, as I told you, to improve the power quality. And then when we are coming to the industrial, commercial, residential side, we are going to use the microgrid. As you know, microgrids is also same like the distributed generations. Then EV charging infrastructure. Even now we have a different EV charging infrastructure in different places across the country. Then energy management systems, AMI, we are going to take this advanced metering infrastructure. So what is an advanced metering infrastructure? If we see, it is a smart meter. We will see in detail what is a smart meter. So we have a now meters, it is with the different versions, mechanical, electronic meters. Then we are having now a smart meter. So we have done some work in the smart advanced metering infrastructure, that once we will discuss. Then energy storage, then we are having a smart appliances, right? And then communication infrastructure, cyber security. Cyber security is also an important thread in the electrical network, especially when you are having a nuclear power plants. The nuclear power plants should not be attacked by the cyber attacks. because they can able to take over the nuclear power plant. So we need to have some protection against the cyber attacks also. We are having that facilities in the smart grids, and also workforce management. So earlier days the workforce management is very difficult, but now we can able to identify where the workforce is, like the employees where they are now, especially when they are roaming to solve the problems. That time it is very easy for us to determine where the workforce is. Okay. So here in the smart grid technology landscape, some of them they are developed, some of them they are developing, some of the development it is very fast, some of the developments it is in a moderate level. So here if you see communication and security of the smart grid technology, the maturity level it is developing, the development trend it is becoming fast. The same if we see electric vehicle, large scale renewable generations, distributed energy generations, microgrids, all of them also developing and fast. Metering it is mature fast. So this is the data which we are talking in aspects of all over the world. But if we look in India, the smart metering it is not implemented the entire country. It is implemented in selected cities. They are working on it under the smart city concepts. Then we are having advanced system operation management, system planning, home building automations, islanding aggregated load. So some of them they are under developing. They are developing in a fast phase. Some of them they are developing in a moderate phase. Rising electricity demand, because earlier days electricity is not very important, but the global population they are global population is increasing, as well as if you look the demand for the electricity is increasing. As you know, all over the world the industrial industries are coming up. When the industries are coming up, we need to supply the electricity to the industries, and yes, it is producing jobs and developing the country's growth. Now if we see about 12.6 percentage of the global populations it is not electrified, and also even some of the countries they are electrified, we can say it is 100 percentage electrified, but we cannot say that all this um, the entire country it is getting the electricity all the 24 hours, so they are having a limited hours of supply. Okay. USEA projects its aim to increase the world electricity usage 28 percentage by 2040. And then electrification of transport is very very important. So here just I mentioned some of the countries in some continent they are not having electricity. Their electrification percentage is, we can say, it's less than 20 percentage for the entire country. It's very uh, low. Population is without electricity, you can see 7.6 billion, that is the 12.6 percentage of populations in the world they are not having the electricity. Okay. So now when we are moving to the distributed generations, we know that distributed generations it is mainly in the places where we are having the remote populations, right? So power generations we are going to have it in the same place where the consumption is going to happen. We are going to generate the power in the same place and we are going to supply them, so that this will reduce the cost, because when you are transmitting the generated power you are going to have the transmission lines and distribution lines, and the complexity and the efficiency is also, complexity is reduced and the efficiency is going to be improved, and the reliability is high, and the power generations it is going to be in a smaller scale. These are the advantages of the distributed generation. So we are having a different types of distributed energy resources. We have combined heat power, fuel cells, hybrid power systems. We can use solar and wind. Then we have a micro combined heat and power. Then alone we can use solar photovoltaic. We can use wind power systems alone. We can use RC reciprocating engines. Then we have other power plants like a tidal, ocean thermal, but it is not developed a larger level. In some countries they have the tidal and ocean thermal power plants. Then biomass and biofuels, we are using micro small turbines. Like we cannot able to construct a large hydropower plants, because large hydropower plants it's need a huge space. So we can able to have a micro turbines. We can able to have a power plants. So the smart grid, it proposes this distributed generations. The conventional grid, it is using a centralized power generations. So central power stations transmit, distribute to the consumers. But when we are coming to the distributed generations, it is having its own power plants like photovoltaic power plant. It is going to have a wind power plant. It is going to have a CHP power plant. It is going to have a local CHP plant, so that it is easy to supply the consumers when we are going for a distributed generation. So this is an example of a solar PV potential availability all over the world. So if you look the countries like Australia, the North African and Southern African countries, and some part of America, North America, and some part of South American countries, and some part of India, they are having a lot of solar PV potential, so that we can able to go for solar PV potential, so that we can able to contribute in reduction of the carbon emissions, so that we can stop using the fossil fuel consumptions, right? So when you are coming to the smart grid, it is in different locations. Like we can say smart substations. That is one of the major important part of the smart grid. Smart substations, we can see we are having a conventional substations. That conventional substations, they are not having a lot of productions and monitoring and communication part. But now when you are coming for a smart substations, that smart substations, it can able to connect to the other substations through the communication way, and also we can able to monitor the smart substations, and also it is easy for us to protect the power lines and the equipments when we are going for a smart substations. Then um, production monitoring and control devices, intelligent electronic devices. These intelligent electronic devices, it is used in the smart grid systems, so that it can able to sense so many informations. Like in the intelligent electronic devices, we are having to use these devices for exchanging the data. Sorry, organizers. I don't know. Someone is writing. Hello, hello, organizers. Someone is writing. I don't know.
Yes, sir. We will control it, sir. We will check, sir.
Okay. So now we are going for the other control systems, like we can say as SCADA systems, supervisory control and data acquisition systems. In the supervisory data control and acquisition systems, it is used in different places, like it is used in the utility grid, it is used in the oil gas industries, it is used in different manufacturing units like packaging industry and water plant. So in the SCADA systems, what we are going to have, just I want to show you a picture here. If you see the SCADA systems, it is going to have a national SCADA energy management system, and the regional SCADA energy management systems. So now we are having a generation plant, a transmission plant, and distribution. All of these, they are going to have a substations. So now we are going to have a remote terminal units. These remote terminal units, it is going to have a sensors. The sensors, it is going to monitor the substations. So the monitored and informations through the sensors, it is going to be transmitted to the regional SCADA EMS. This RTU itself, it can able to take a decision based on the condition, like maybe the voltage is high, or the temperature is high, or the pressure is high. Based on the, it can able to take the decision. The recorded informations, it is going to be transmitted to the regional center. From there, it is going to transmitted to the national SCADA center. So when we are talking about the SCADA center, so when we look here, we are having a communication. The information is transmitted. The information is transmitted in different ways. So we are going to use a different types of communication links. If we see the communication links, we are having a SCADA master, and then you are having a remote terminal unit. So this remote terminal unit, it is going to have a actuator. it may have a meter, it may have a PLC. So we are having these IED devices. These IED devices, it is going to detect the situation, like maybe as I told you earlier, what may be the frequency, what is the voltage, what is the current, every data, it is going to be determined by using this remote terminal unit that sends the informations. It is going to be transmitted to the master control center or the national control center through different types of communications. We can use a fiber optic communications, we can use a radio microwave communications, any type of communication medium we can use in the SCADA systems. Okay. Now we are talking about the SCADA, but the SCADA, it is having some drawbacks of having a phase angle measurement, time delay, and synchronization. So that problem can be eliminated by using PMU units. So PMU units, it can able to determine the data like frequency, voltage, or current, or pressure. All these informations, it can be determined in less minutes. Like within 1 minute, 1 second, we can able to record the more data at different instances, so that it is very easy for us to monitor, and we can able to take some precaution activities if the data is an abnormal data. Like you can see here, we have a data comparison between the SCADA and phasor measurement unit. Phasor measurement unit, it is going to have a data measurement 30 times per second, so that we can able to get an accurate information. So like what is the disturbance in the voltage, what is the voltage magnitude, all these informations, it can be determined. It is better than the SCADA. Okay, now we are entering into the smart grid communications. Without a telecommunication infrastructure, power system, it is not going to work properly. So for every operations, if we are talking about generation, monitoring, production, control, we have a data and voice communications. If there is no communication between the production and control devices, it leads to a failure of the systems, because when you are having a production device or a control device, that production and control device, it is going to see whether there is any abnormal in the power system network. If we don't have any communication between the production and control devices, automatically what is going to happen is we cannot stop the abnormal situations. So there may be a fault, it is going to happen, that may affect the entire electricity network. So communication is very, very important. In classical power systems, the conventional grid systems, if you see, the telecommunication is only used for reliability and continuity of operations, but it is not like that in the smart grid. In smart grid, we are going to use this telecommunication technologies for every operations. That's what you can see here. You mentioned like it is used in the monitoring, production, control, and everywhere we are going to use the telecommunication technologies. The success of operation of future intelligent energy networks or smart grids, it is going to be based on grid integrated near real time communications between all these elements. So, we are having a generation, transmission, then distribution, then we are having at the end consumers. So the consumers, they are going to be the loads, right? They are the people going to use the loads. So we need to have a good communication between all of these four, otherwise we cannot able to operate the smart grid properly. So previous classical power systems, if you look, you have a coal power plant, and then you have a transformer, you are transmitting, then you have a transformer, again you are distributing to the consumers, right? So if you see the power flow direction, the power flow is only in one direction, and if you see here, the communication is also not all over the places. But when we are coming to the communication and structure of smart grids, you can see we have a power plant, the same, and the same time we are having a solar, we are having a batteries, we are having a wind power, and then we are supplying directly to the consumers, and then we are having a electric vehicle charging stations. So the if you see, the communication, it is in all the places. So we are having more telecommunication technologies used in the smart grids. So in that, especially we are going to see about advanced metering infrastructure. The advanced metering infrastructure, how it is different from the existing meters, or smart meter, how it is different from the existing meter. So the existing meter, you can see this picture. This picture shows the history of the smart meter. If we look the smart meter, we have a mechanical meter in old days. So here it is very difficult for us to even identify how much electricity you consumed in this month. But this one which we are having mostly in our houses nowadays, electronic meter. This electronic meter we can able to see how much here the numbers digits. Then we can able to subtract it from the previous one, then we know how much we consumed in this month, right? But when this coming to the smart meter, the smart meter, it is having a lot of advantages, like it is going to have a remote recording, dynamic electricity price, and it is going to give you a real-time informations like what time you consumed electricity. Like based on that consumption information, you can able to reduce the consumption. If you know, no, I consumed a lot within that 15 days, then you can able to reduce, or you can able to take some necessary activities to reduce the consumption in the remaining 15 days. Then power quality monitoring, then firmware upgrading, and then feedback, like you can able to communicate to the utility grid through the feedback communication also. So these are the advantages when we are coming to the smart meter. So if you see the conventional meter, you have a residential, industrial, consumer conventional meters. The manual, a person is going to come to your house to see what is the consumptions, then they are going to give you a manual billing. But when you are coming to the smart meters, you have a bi-directional communications. So you have a smart meters. That smart meters, it is going to be interacted to the database, right, through a communication interface protocol and a gateway, so that this communication recorded informations, it is again transmitted to the users, so the users can able to see how much consumptions they are done in that month. So you can see here your smart meter measures and records electricity usage every 30 minutes. Data it is transmitted to the electricity distributors who own the managed grid and poles and wires. Then energy providers, utility grids, make consumption data available to you via the web portal, or even you can receive the information in your mobile also, so that we can able to monitor the consumption or the usage, and also you can able to see the offers and better manage cost. So here I mentioned compare offers and better management cost. It is like in future, if you see the peak load, normally the peak load it is happens in the morning 6 to 9, then evening after 6 to 9, right? This is the time everyone we use electricity more. So in that time the consumption is more. So in future there may there is some provisions like in this peak time, if you use less electricity, you are going to be charged less. So in that case, we can able to adjust your bill by changing the usage of electricity, or by reducing the usage of electricity at the time of the peak load time. So here we are having a structure of a smart meter. So the smart meter can use a microcontroller, maybe a ARM controller or an FPGA controller, and you have a breakers. So you have a AC supply and you have a DC supply, and you are going to have a production control. Then this smart meter structure, it is connected to the power utility or a distributor control system, DCS, through a wireless medium or a wireline medium or a fiber medium. And also it can be connected to the local wireless network systems also. Now if you see smart grid communications, we are having a smart meters. That smart meters, it is going to be a bidirectional one, communicating with the data concentrator. The data concentrator communicate this collected informations to the utility or a distributor control systems through a wide area network. And also we can able to connect to the others also through the wide area network, so that each individual house, how much they are consumed, that can be determined by the smart meter, can be transmitted to the utility through the wide area network. So now telecommunication technology, it is very important in the smart grids. So it is used in the smart meters and appliances, it is used in the smart grid and in the electrical grid. And also we need to have a communication between the grid components, especially as we have seen already, production and control, and also to monitor and to make a synchronization. So synchronization normally we used to do when we are connecting your generation plant to the transmission system. So we need to have a synchronization. These all operations it is going to use the telecommunications. So several performance criteria that is needed for successful communications like latency, data rate, and reliability. So here what we are done, just I want to go directly. Okay, I am just here showing you the advanced metering infrastructure. So the some of the work what we are done, we used the advanced metering infrastructure. The setup we developed by using NS2 simulators, and then we try to see if there is any cyber attacks. If it happens, how we can able to protect the data, because the data is very important. So you have a smart meter. That smart meter it is communicating with the utility through the wide area network. So the information is stored, and that informations your consumption it is sent back to your mobile, or it is going to be emailed to you. So we need to protect these informations. There may be a possibility for tampering these informations, right? So that's what we have here. We are having advanced metering infrastructure. Advanced metering infrastructure, a smart meter that is going to have real time data, so that we know how much we are consuming. Like when we are having a season, different seasonal changes, we may consume more, right? We may use a air conditioner, or we may use a heater, and then we can avoid the manual readings when we are going for the smart meter. And also we can able to use the AMI. When we are using this AMI, it can able to help us to use the electricity in a more efficient way. So here you can see the advanced metering infrastructure. So you are having a data management systems, right? So we are using a wide area. The data is collected in a concentrator. Then that informations it is going to be given to the smart meter. So these bidirectional communications, you can able to get informations from the smart meter to the data management systems, or from the data management systems to the smart meter. Okay. So, okay. Okay, we are having a different algorithms in the advanced metering infrastructure, because we need to protect the information. There should not be any tampering, like any vulnerability should not be happen. So how we are going to do to avoid the denial of service attacks? Okay, inefficient key management method. So we are having a different methods to protect the informations which we are getting from the advanced metering infrastructure. So what we did first, initially we want to develop a infrastructure like how the advanced metering infrastructure it looks by using a simulation. So we developed a infrastructure model of advanced metering systems by using a NS2 simulations. Then the data which we are transmitting from the smart meter to a storage system, it should have a authentication. So we developed a authentication, a key based systems that is going to secure the communication between the smart meter and the other nodes in the network. In the same network, if we are having a intrusion detection systems, that intrusion detection systems it going to detect the attacks which is happening in the network, so that if we can able to avoid these attacks, it's easy for us to share the proper informations, like what is the consumptions. Otherwise the information may be tampered, that may affects the utility grid. So we used some simulations method. So here if you look the architectures that what we developed, so infrastructure creation, like in the infrastructure creations we are having a base stations, then we are having a sensors that is going to be like a sensor which is going to sense the informations within the smart meter. Then we are going to have a gateway, and we are going to have an user. Then this is the first part of the proposed systems. Then we are having the second part. The second part it is going to have the security algorithms, and then the security algorithms it is going to introduced to send the data and to receive the data. So we are going to have a data encryption and a data decryption, so that we can able to see what is the data it is sent and what is the data we received, whether this information is same, the send data and the received data is same. Then we are going to have the third part. The third part it is the communication between the sensors and the utility grid. Okay, so here bidirectional communication of network components in the proposed model. So you can see here we have a sensors. That sensors, it is in the smart meter, collect the information like what is the consumption and transmit that informations to the base station. From the base station, that information goes to the utility provider through the gateway. Again through the gateway it comes to the user. So you can see it is a bidirectional communication. So base stations receive the data from the sensor and it transmit to the utility provider. From there we get the data. Here in these systems we used the configurations, configuration of nodes. If you see, we used the MAC 802 and we used the wireless channel communication, and in antenna we used the omni antenna because it can able to be a covering a 360 degree, and also it is a directional antenna. So the simulations, it is done by using the network simulators. So you can see here the virtual output of the simulations. The network simulations has two types of output, which are the virtual output and the statistical output, which is shown in the picture. Here if we see the statistical output, here it shows the different delays, throughput, and also what are the packets dropped and the dropping ratio and the lifetime. So in this, we used four different methods. The four different methods are concealed based security scheme, elliptic curve cryptography authentication scheme. Then we used authentication based data confidentiality systems, secure and efficient anomaly detection. So as you know, we need to develop a simulation model for the AMI infrastructure. Then we need to share the data with the encryption and decryption. Then we should avoid any cyber attacks also. These all it is achieved by using these different methods, and these results are compared. So if you see the CBSS which we proposed in the AMI, we are having a base stations, web servers, utility center, customers and smart meter nodes, and we have a communication between the utility center and the customer smart meters. So here the data flow, it is from the smart meter to the utility center, and it return back to the customer. And also we can see we used different risk which we faced. One is alteration of data in the transmission and wrong predictions, which is leads to the financial loss, and there may be a possibility of the power outages with severe impacts. And then we used the next one, elliptic curve cryptography. So here I just want to directly show what is the simulations parameters which we used for the CPSS and the ECCAS. So the number of nodes which we used is 101, and the area 500 into 500 square meter, range is 100 meter. And then we have the transmission energy and receiving energy. And we compared the results for different conditions. When we are comparing the results for the different conditions, we can see here the simulation time versus packets dropped. We have the comparison between the CPSS and the ADCS. So we can say during the transmission, CBSS, if you see CBSS during the data transmission provides better packet trapping, because you can see this blue one graph, it shows the CBSS, then this red one, it shows the ADCS. So this ADCS, if you see, that is the authentication based data confidentiality systems. And then we compared with others also, like simulation time versus total consumed energy. The CBSS consumptions, it is less compared to the ADCS. And also security reduces for the forged data traffic in the AMI network, which is showing the energy consumption, it is reduced when in the sensor nodes. Then we are using this ECCAS, that is using a simulation time of 200 seconds. Then field, it is 500 by 500. Using a omni antenna, as I told you earlier, channel is a wireless channel. Then MAC type, and it is using a advanced on-demand vector protocol, and then number of nodes it is going to be variable. This is tested in different instances, like we are having a random instances, like different scenarios, like we have a scenarios of 101 nodes of each method, 150, 200 and 250. So when we are having these each methods, this is like depend upon the varying population of the network. So in the AMI communications, we developed this, and we have seen what is the number of nodes and the packets dropped between this ADCS, CBSS, and ECCS. ECCAS, it is having a less number of packets dropped from this graph. Then we have seen the total energy consumptions between this ADCS, CBSS, and ECCAS. ECCAS, it is having a less energy consumptions. Then we used the another method which is going to help us to avoid the cyber attacks like intrusions. So when we are seeing these intrusions, this is also using the same protocols, channel, and everything. The parameters are same for this SEAD also. The SEAD, that is the secure and efficient anomaly detection model. So here also we are using the network environments for each method. We are taking a scenarios. So the first scenario we are taking 110 nodes, second scenario takes 120 nodes, third scenario takes 130, and fourth is 140, and the fifth one is 150 nodes. So at the end, we compared all the results. So average energy consumption, which one is giving a better energy consumptions, and the throughput, which one is giving a better throughput. Okay. So if we see from these figures, if we can see this from the figures, which is covering all of them, all the proposed methods. When we are looking all these proposed methods, we can say if you see this ADCS, the ADCS, it is increases as the number of nodes increases. When you see the number of nodes increases, the ADCS, the average energy consumption is increases, right? If we see the throughput, the number of nodes increases, the throughput is also increases. You can see here in the number of nodes increases from 110 to 150. You can see the graphs of the ADCS, CVSS, ECCAS, and SEED. It is also increasing. But when we see in this all SCAD, you can see SCAD, it is going to have a highest throughput when we are comparing it with all the methods. So intrusion detection, it is also detected by using the SCAS. So these are the results which we get when we are having the advanced metering infrastructure communication, how we developed a smart meter systems in the advanced meter infrastructure. And these are the references which I used for the presentations. And thank you.
Thank you, sir. Thank you, Professor. Thank you for your valuable presentation, sir. Actually, your presentation give lot of insights in terms of implementation of NS2 environment, implementation of the data packets, and how the data packets that can be dropped during the transmission of data. So all those things you clearly explained. These insights really help a lot for the professors and the industry persons, those who attended this session. And also, you clearly given the details about the comparison between the energy that can be consumed. So all these results are we are able to see very clearly. Really, on behalf of St. Joseph College of Engineering, along with the coordinator, Dr. P. Chennai as our coordinator, and myself, Dr. Or Dinesh Kumar, definitely we will extend our heartfelt thanks for your acceptance of this FTP invitation and your wonderful presentation. Thank you, sir. Thank you so much. Dear participants, if you have any queries, you can post your queries in the chat box. Our resource person will clear your doubts. Sir, open the outlets. Participants, if you have any queries, you can post in chat box. Sir, there is a question in chat box from the participants. How can Wi-Fi and optical wireless communication contribute to secure and high-speed smart grid communication?
What is the question, sir?
How can Wi-Fi and optical wireless communication contribute to secure the high-speed smart grid communication?
Yeah, actually, if you look, we are using different types of communication technologies. We are using like wireless communications, we are using optical fiber communications, we are using different communication technologies. It's depend upon the requirement, like where we are going to use. Like if you are taking a communication link between a production and a control in the power systems, there we are going to use a wired communications. But if you are having a control from the substation to the transmission line control systems, we are not going to use a wired communications, we are going to use a wireless or an optical fiber communications. So it is used in different locations, that is depend upon the systems which one you are going to use, whether you are going to use the communication technologies within the IED devices or between the AMA structures to the substations, where you are going to use. Depend upon that we can use or we can select the particular type of communication mode.
Dear participants, those who want to ask questions or discuss with the expert, you can unmute your mic and speak to him. You can ask your queries.
Dear participants, if you have any queries, you can unmute your mic and you can interact with our resource person. Dear participants, if you have any queries, you can unmute your mic and interact with
Sir,
our
good
expert
evening, sir. Good
now.
evening, sir. This is Ramasatish from Bangalore, Karnataka. Sir, I have one small doubt. How safe
And one more
is
questions
this
received
public?
in chat box. What are the major cyber security threats to smart grid communication networks and how can they be mitigated?
What the question, sir? Yeah,
Sir,
we are having different types of protocols for the cyber threats. We can use these protocols and that one can able to help us to protect the, like if you see
sir,
example,
Professor,
uh,
sir.
hello, can you hear me? Hello,
Yes,
hello.
sir. We can hear you, sir.
Yes, we are having different types of we are having a different types of protocols which we can able to use against the cyber threats, the cyber attacks. Even if you see around, I think 2000, I think 2013 around, there was an cyber attacks against the Kudangulam power plant. So cyber security is also an important sector. Always we are using a different protection schemes against the cyber attacks. Hello, can you hear me?
Yes, sir. Yes, sir.
Yes,
Sir,
sir. We
and
can hear you.
yes, sir. And one more question, sir. What is the difference between a Wi-Fi and Li-Fi?
Can you hear me? Hello.
Yes, sir. Yes, sir. It's audible. There is one more question in chat box. What is the difference between Wi-Fi and Li-Fi?
So normally, if you see the Wi-Fi, it uses the radio waves. But if you are using the Li-Fi, it is going to use the light. And also, when we are comparing Li-Fi versus Wi-Fi, we can say the Li-Fi it is going to be a faster one, but we can say we cannot able to use it for a long range. It can be used for only a short range. So we have some drawbacks in both. Especially in the Li-Fi, we need a light source because this light source only it can be used for the transmitters and the receivers to function. So this may be a problem when we are using a Li-Fi.
Sir, I have a question.
Yes, sir.
Hello.
Yes. Yes, I can
Sir,
hear you, sir. Yes, yes, I
yes, sir.
can hear you.
Sir, this many people are now moving towards electrical vehicles. Is it really safe to use public charger, fast charger, sir?
Yeah, that is not that is not safe. Like example, if you are looking about the security concerns, there
Yes,
may be
sir.
a possibility of theft and data privacy
Ha,
issues
ha, ha.
like yeah, personal informations it can be stolen. Yes, it is not safe.
Okay, sir. That's what I had on doubt. Personally, I'm using. That's why, sir. Yeah. Thank you, sir.
Yeah,
Thank
by
you.
using USB ports, there may be a possibility. There may be a possibility of the attacks. Yes, sir. Yes, it's not safe.
Yes, sir. Thank you, sir.
Yeah, we can say it is around maybe 70 to 70% it is okay, but it is not, we can say 100% safe.
Thank you, sir. Thank you for your wonderful session, sir. On behalf of St. Joseph College of Engineering, as a co-coordinator along with the coordinator, I would like to once again thank for your wonderful presentation, sir. Thank you, sir. Thank you so much, sir. Dear participants, I request all the participants to unmute your video for the photo session.